Hello everyone. I hope you all are doing well. Today, I'm going to explain a very important and commonly confusing topic in C++, which is the difference between structure and class. At first glance, structures and classes look almost the same. Their syntax is similar, they both can store data, and they can even contain functions. Because of this, many beginners assume that they are interchangeable. But in reality, structures and classes serve different purposes, especially when we talk about object-oriented programming, or OOP. Understanding this difference is extremely important because it helps us write better, more secure, and more organized code. In real-world software development, choosing between a structure and a class can affect how safe your data is and how your program behaves. For example, think of a public notice board versus a bank locker. A notice board is open to everyone. Anyone can read or write on it. That is similar to a structure. A bank locker, on the other hand, is private, only authorized people can access it. That is similar to a class. So in this presentation, we will start from the basics, understand what structures and classes are, see examples, and then slowly move towards understanding their differences, use cases, and importance in programming. Let's begin with the basics. In C++, both structures and classes are known as user-defined data types. This means they allow programmers to define their own data types instead of only using built-in ones like int, float, or char. The main purpose of both structures and classes is to group related data together. Instead of handling multiple variables separately, we can combine them into a single unit. This makes code more organized, readable, and manageable. For example, if we want to store student information such as roll number, name, and marks, it doesn't make sense to create separate variables everywhere in the program. Instead, we group them into a structure or class called student. Another important point is that both structures and classes can also contain functions. These functions usually operate on the data present inside them. This allows us to keep data and the logic related to that data in one place. However, even though structures and classes look similar in definition and usage, they are designed for different intentions. Structures are traditionally used for simple data storage, while classes are designed for modeling real-world entities with behavior, rules, and security. So while both help in grouping data and functions, their behavior, access control, and use cases differ significantly, and that is what we will explore next. This topic is important because many beginners make the mistake of thinking that structures and classes are exactly the same, just with different names. The syntax may look similar, but the behavior is very different. In object-oriented programming, concepts like data hiding, encapsulation, and security are extremely important. Classes are built specifically to support these ideas, whereas structures are not. Let's take a real-life example. Imagine a college database system. If student marks are publicly accessible and editable by everyone, anyone could change marks, which is dangerous. That's similar to using a structure where everything is public. Now imagine the same system designed so that marks can only be modified through proper authorization and rules. This is what a class provides: controlled access. So, understanding the difference helps us decide when to keep data open and simple, and when to protect data and enforce rules. This topic also matters in exams, interviews, and real projects. Many interview questions are directly based on the difference between structure and class. In short, learning this difference is not just about syntax, it's about thinking like a programmer and choosing the right tool for the right problem. A structure is a user-defined data type that is mainly used to group related data items under a single name. The most important feature of a structure is that all its members are public by default. This means any part of the program can directly access and modify the data inside a structure. Think of a structure like a transparent box. Everything inside it is visible and accessible to everyone. There are no restrictions. Structures are commonly used when data security is not a concern. Data is simple, and we only need to store values. For example, storing coordinates like X and Y, storing product details, or reading file headers. Because everything is public, structures are fast and easy to use, but they are not suitable for sensitive data. In early programming languages like C, structures were heavily used for data grouping. C++ kept structures mainly for backward compatibility and simple data handling. So to summarize, a structure is best when you want simplicity, you want direct access, and you don't need strict control over data. Let's look at this simple structure example. Here, we have a structure named student with two data members, ID and grade. Because this is a structure, both ID and grade are public by default. That means we can access them directly using an object of the structure. For example, if we create an object S1, we can easily write s1.id is equal to 10 or s1.grade is equal to A without any restriction. This is similar to filling a form where all fields are open and editable. There is no validation or protection. This is useful in scenarios where data is simple and doesn't need security. For example, reading data from a file, transferring data between functions, or storing basic records. However, the downside is that anyone can change the data, even accidentally. There is no control mechanism. So while structures are easy to use, they should be used carefully, especially when data integrity matters. A class is the foundation of object-oriented programming in C++. It acts as a blueprint for creating objects. The biggest difference from a structure is that class members are private by default. This means data inside a class is hidden and cannot be accessed directly from outside. Think of a class like a bank account. You cannot directly access the money. You can only deposit or withdraw through proper methods. This concept is called encapsulation, where data and functions are bundled together and access is controlled. Classes help in protecting data, enforcing rules, modeling real-world objects. Because of these reasons, classes are used in large applications, real-world systems, and professional software development. In this example, the ID variable is private, which means it cannot be accessed directly. To modify it, we use a public function called setID. This allows controlled access to data. This approach ensures data safety. For example, we can add validation inside setID to prevent invalid values. This is exactly how real-world systems work. Access is never direct. This is the power of classes, control, security, and structure. The most basic and important difference is the default access specifier. In structures, everything is public by default. In classes, everything is private by default. This single difference completely changes how both are used in programming. Structures encourage openness. Classes encourage protection. That's why classes are preferred in OOP-based designs. Data hiding means protecting data from unauthorized access. Structures provide little to no data hiding. Classes provide strong data hiding using private members. This makes classes ideal for sensitive systems like banking, authentication, and databases. Both structures and classes can contain functions. But in practice, Classes rely heavily on functions to control behavior, while structures are mostly data-focused. This difference aligns with their purpose: simplicity versus object-oriented design. Thank you everyone for watching this presentation. In this video, we understood the difference between structure and class in C++, starting from their basic definitions to how they are used in real-world programming. We saw that although both look similar in syntax, they are designed for different purposes. Structures are mainly used for simple data grouping, while classes support object-oriented programming concepts like data hiding and encapsulation. Understanding this difference helps us write better, more secure, and more organized code. It also helps us choose the right data type depending on the problem we are trying to solve. I hope this explanation made the concept clear and easy to understand. If there are any questions or doubts related to this topic, they can be discussed further. Once again, thank you for your time and attention.